So, any questions over what we did last time? Everybody's good to go with sections 1.1 and 1.2? Okay, well, I'll warn you right up front. Today I'm supposed to cover section 1.3, but in my last class I did not quite get that section all the way done. So what does that mean in terms of the syllabus? Remember what I said about homework due dates? The homework won't be due until I actually finish the section. So I'll end up finishing it Monday, and then it won't be due till Wednesday. Got it? So I'll have to go in and adjust the due dates. So just for purposes of keeping me remembering what all I'm supposed to talk about, save a little bit of writing time on the board, I've got a PowerPoint presentation here. And I won't read every single one of these slides, or you won't have time to write down everything off of every one of these slides. But I'll kind of indicate the important ones. But just remember that everything that's in this slide is also in the text. It's in the book. So if you don't get everything scribbled down, don't worry about it. Just go to the book, fill it in. Right? It's more important that you listen to what I'm saying and just try to understand the concept. So the first thing, this section and the next section are all about design of studies. Right? How do we design a study so that we get valid results out in the end? So these are kind of the steps that we would go through as a research team to come up with the best design for conducting a certain research study about a particular hypothesis. Okay? As a consulting statistician, I can tell you, and this happens unfortunately a lot, the worst thing that I hear from a client is they walk into my office, they plop down maybe a CD, and they go, I got this data. And I don't say it out loud, but I'm thinking to myself, well, then it's probably too late. What I want to hear as a statistician is, I got this idea for a study. Can you help me design it? Because fancy schmancy statistical analyses, number crunching, isn't going to save a poorly designed study. Right? So the design is actually a really important part of this whole process. So we have to do all of these things in a very, what the heck? Oh, I got to be careful where the mouse goes, I guess. So this example says identifying population and variables. The first thing you can do, it was on that list that I kind of breezed through, but the first thing you need to do is figure out, well, what question am I trying to answer? That's establishing your hypothesis. You've heard of the scientific method, right? You learned that in probably 6th grade. The scientific method. You form a hypothesis. What do you do next? You guys need to go back to 6th grade. You form a hypothesis. You design an experiment. You conduct the experiment, collect the data. Then you analyze and see if it supports your hypothesis. If it doesn't, you cycle back up, you change your hypothesis, and you do it again. Right? Well, neurologists want to study the effect of vitamin C on nerve disorders. The goal of the study is to see if taking an intravenous dose of vitamin C will reduce the amount of nerve pain reported by patients. Identify the population of interest and the variables in this study. And I'm going to add to that a little bit, but what's the population?
People with nerve disorders.
Okay, people with nerve disorders or nerve pain, right? And wait, is it all patients or only in a certain region? It really doesn't say, does it? It just says, we want to know about nerve pain. Right? So the way it's worded, the population is all patients with nerve pain. Right? So what are the variables that are important in this study? Remember what a variable is? It's a characteristic we collect that can change from subject to subject to subject. What are the important variables here?
The dose of vitamin C given.
Okay, the dose of vitamin C given. That's known as our explanatory variable. Ooh, there's a word. Explanatory. What does that mean? To explain. It's a variable that we at least hope will explain how they respond. So what's our response variable? Nerve pain. We're going to have some kind of a pain scale that we say, please rate your pain or whatever, right? But so our variables, our two most important variables are explanatory variable of vitamin C dose. Now, a good study will have a group that gets the vitamin C and a group that doesn't, right? So then you're varying that variable. And then we ask them about the nerve. I knew that was going to happen. I'm just really lucky that the tripod didn't go. If that happens and I fall down and get knocked out, you're free to go. Okay. The two main types of studies that you can conduct are observational studies and experiments. Now, you may find in your book, if you're following along, this same box. Only a student had to point out to me last time that it's purple in the book, and it's some other color up here. I'm kind of colorblind, so I'm not sure what color that is. It looks tan to me. Is it tan? All right. Okay? So anyway, I added to the definition for both of these from what's in the book, because I don't feel like the definition they gave is quite complete. All they say in the book is an observational study observes data that already exists. I said data or conditions. Because even later in the section, they'll say one type of observational study follows people long-term through time. Well, that data doesn't already exist when the study starts. They have to wait for that data, right? But the main hallmark is you're just observing what's already happening. Whereas an experiment is designed to generate the data and assigns conditions to help identify a cause and effect relationship. Okay? So this is the part I added. And assigns conditions. That's not in the book. Right? That's really the hallmark of an experimenter, of an experiment. If the researcher decides who gets what treatment, then it's an experiment. If the subjects decide which treatment they use, that's observation. Okay? And it says here that an experiment can identify cause and effect. Well, that's the problem with observational studies. We simply observe what is happening, do not assign conditions. Conditions is a little broader term than treatments, but I'm going to put treatments in parentheses. When we say treatments in statistics, I started to step out and say, shut up. But I thought I might get punched. We use the term treatment kind of in a generic sense. It doesn't always mean that we're actually giving some kind of a drug or a treatment, or something, but it's just, a condition. We might prescribe exercise, or we might prescribe that they have an hour of tutoring in the evening, something like that. But we still call that a treatment, all right? But an observational study does not assign what those conditions are. And it cannot establish causation. Okay, I'll come back to that in just a second. An experiment the researcher I got my A in the wrong spot. Assigns treatments. Can establish causation. So if you want to prove cause and effect, you need to do an experiment. Observational studies can hint at cause and effect, but there's no guarantee. And here's a little example. Suppose that I am interested in whether or not regular exercise can lower your cholesterol. It's a valid hypothesis. You ever heard that exercise can affect your cholesterol? Yeah. So I don't have the benefit of a good statistician to ask, so I designed my own study. And I think, well, let's see. I need some people who exercise. So I'm going to go down here to the Student Rec Center. I'm going to go in there and I'm going to recruit 50 people who are in there working out. See if they'll be in my study. And I take those 50 people and I draw blood and I measure their cholesterol. Okay? Then I think, because I know a little bit about design, I need a control group. I need some people who aren't exercising. So I go down here to McDonald's and I recruit 50 people who are in McDonald's to be in my study, and I draw blood from them and I measure their cholesterol. And lo and behold, when I analyze the data, guess what? We have lower average cholesterol in the exercise group than in the non-exercise group. Did I establish causation? First of all, what kind of study did I just do? Observational or experiment? Observational. They were already doing what they were doing. They self-selected to be in the exercise group or the McDonald's group, right? So I didn't assign that. So that's an observational study. Why can I not say that exercise affects cholesterol based on my study? I found an association. Those that were exercising are associated with lower cholesterol. Those that weren't are associated with higher cholesterol. But association does not imply causation. Why not? Yeah.
To give you like the many factors that go into that, your genes that you have.
Okay, there could be many other factors, right? We call those factors confounding variables, right? Confounding variables. Now, you mentioned genetics. That certainly can affect cholesterol. In fact, they're now thinking that that probably has more to do with it than just about anything else. But what else? And I purposely designed my study this way as a bad study. What other variable did I throw into the mix that could explain the difference in cholesterol?
Salt. Their diet.
Diet. McDonald's, somebody said salt. Yeah, the diet. It might not have anything to do with exercise at all. It's the fact that these people are eating at McDonald's. That gave them high cholesterol, right? So that's a bad design of a study. It's simply observational, but even if we're going to do an observational study, we can do better than that. But let's do an experiment. How do we design that study as an experiment?
Exercise to the McDonald's people.
Okay, and then I got two groups that exercise.
Take one group of people get cholesterol beforehand, assign however many of those X number of people to exercise, assign X number of people to not.
Okay?
But keep their diets the same.
Keep their diets the same, and you kind of hinted at that. But that's much better, right? And I'm going to add one thing to it. I'm going to make sure that in my sample, nobody exercises at the beginning of the study. because I want them to all be similar. So there may be differences in just who selects to be an exerciser or not. They may have already affected their cholesterol, right? So I'm going to take people who are all kind of very similar. None of them are exercisers. Maybe I'll control what diet they have. Maybe I'll control the age group or whatever. And then I'll take half of them and randomize to start an exercise program, the other half to not exercise. And then in the end, they're very similar groups except for one thing, whether or not they exercised. Then if their cholesterol is lower, and you said draw cholesterol at the beginning. We call that a baseline measurement. I'll take a baseline measurement and then I'll look at the change in cholesterol. If their cholesterol changes after we start an exercise program and nothing else changed, now I've established causation. Okay? I know it was the exercise that caused it. No is a strong word, but I'm 99% confident that it was the exercise. Okay? So back to this idea of confounding variables. Confounding variables, our book doesn't use this term, but a lot of books do. They're also known as lurking variables. And I like the word lurking better because I like to say it. Lurking variable. It's a lurking variable. What does the word lurking make you think of? Creeping around in the shadows, hiding, right? And that's what a lurking variable really is, a confounding variable. It's a variable that the researcher kind of doesn't know about or didn't think about, but it's waiting in the shadows to sabotage the results of the trial. Right? It can make it look like there's an effect when there isn't, and it can hide an effect sometimes when there is. So a confounding variable affects both the explanatory variable and the response variable. If it has an effect on both of those things, then you better well control for it in your design or you're going to have invalid results in the end. Okay? How does diet affect the explanatory variable? Remember, the explanatory variable was exercising. How might diet be related to whether or not somebody exercises? And again, I don't need causation here. I just need that the two things tend to go together. Yeah.
They might eat healthy.
Okay, who might eat healthier?
The exercise group.
Yeah, the exercise group might also eat healthier. The non-exercise group, the group that's eating at McDonald's, they just may have an overall less healthy lifestyle, which makes them not exercise, eat at McDonald's all the time, they smoke, they drink, they gamble, I don't know, right? They're just bad people, right? So when you let people self-select to the treatment groups, then confounding variables can affect that choice. There's something that's known as the healthy patient effect. And things that you read about all the time, like, people who drink cranberry juice have less colds in the wintertime. You hear stuff like that all the time, right? Well, it's because certain people are just really healthy, and they'll do everything they hear about. Ooh, okay, I'm going to start drinking cranberry juice. Well, I didn't get a cold, but it didn't have anything to do with cranberry juice. It's just that I'm doing a lot of other things too that maybe influence cold. I wash my hands regularly, and I don't stick my fingers up my nose, and whatever. So the healthy patient effect can be a confounding variable in all kinds of studies. Okay, so once we decide we're going to do a study, let's say it's an observational study, we need to get a study that is representative of the population. Now, we talked last time about what that means, representative of the population. All right? So we need to spend a little bit of time talking about different types of sampling techniques. Some are good, some are bad. All right? the hope is that we get a sample that is representative of the population. So don't try to scribble all these down. They're in the book, except this last one is not in the book. A voluntary response sample. I'm going to talk about that, and the book, the authors, it is a type of convenience sampling. So I think the authors just talk about convenience sampling and they don't burrow down into this level. But I think this warrants discussion because you see these all the time. But let's start at the top. A random sample is a sample where every member of the population has an equal chance of being selected. Right? So anytime that statement is true, you've got a random sample. Okay? So let's suppose I want to take a sample of Washburn students. And I need a sample of 50 Washburn students. Okay? And let's say, it's a little more than this, but let's say there's 5,000 Washburn students. Okay? So 50 divided by 5,000 is what? 1%? Right? So 1 out of every 100 students I need in my sample. Okay. Well, I'm just going to get a list from the admissions office of all the students, and I'm going to take the first person and the 50th person and the 100th person. I'm going to take every 100th person, because I need 1% of them. I'm going to take every 100th person. Is that a random sample? Does it meet this definition? Does every person on that list have an equal chance of being selected? No. No, why not?
Because not everyone is the 50th and the 100th and so on.
Exactly. Person number 2 is screwed. They can't get in the sample. Actually, they probably would like that. I don't have to be in the dang sample. Right? So that's not a random sample. That is known as a systematic sample. When you take every nth one, that's a systematic sample. It's better than some other types of sampling, but it's not random sampling. Okay? Make it a little bit more complicated, we call it a simple random sample. So it's kind of funny that it's a little more complicated, but then we name it simple random sampling. But the reason it's called that, I'll say in a minute. A simple random sample means that every possible sample of whatever size you need is equally likely to be selected. So every possible group of 50 students has the same chance of being the sample. Okay? So I talked about my systematic sample. Suppose I want to make that a random sample. So I can't start with person number 1. I tell the computer to give me a random sample between a random number between 1 and 5,000. And let's say it comes up with 386. So I go to the 386th name on the list, and I take that person in my sample, and then I go every 100 after that. Is that a random sample? Every member must have an equal chance of being selected. Is that true? It's kind of funny. I got like 5 or 6 people shaking their head no. I got a whole bunch of deer in the headlight look. And Adam nodded. Adam's right. That is a random sample. This Adam. Sorry. It is a random sample because every person is equally likely to be the one that I start with or to be a multiple of 100 away from that person. Right? Since I chose a random starting point, it is a random sample. But it is not a simple random sample. Because not every group of 50 people has an equal chance of being selected. Name a group that cannot be my sample of 50 if I use that technique. I start with number 386, and I go to 486 and to 586. And
I don't know what 386 is.
okay, so 387. Yeah. A sample that has person number 386 and person 387 in it, that's a group that cannot happen together. So that doesn't meet this requirement. So how do you do a simple random sample? I need it to be so that every possible group has an equal chance of being the selected group.
Every group of 50?
Right. I need all possible groups of 50 to be equally likely to happen. How would you do it?
Randomly.
Go ahead.
Randomly have the computer select them all.
Have the computer just select 50 of them, right? What I was waiting for somebody to say is, put all the names on slips of paper and put them in a hat. Draw names from a hat, right? And that's the way you think of it. We don't actually use hats and slips of paper anymore. We use computers to do it. But it's the same idea. You just jumble them all up, reach in, and pull out 50 of them. That's a simple random sample. It's just as likely to be any group of 50 as any other group of 50. Right? You ever play the lottery? The Powerball lottery, there's, I think, 59 white balls with numbers on them in a big bin, and they tumble that bin around, and then they pull out 5 of them. Any group of 5 is just as likely to happen as any other group of 5. That's a simple random sample. Right? So the statistician will tell you, don't play the lottery. That's just a dumb idea. But they'll also, I'll give you this advice. If you do play the lottery, pick a combination of numbers that nobody else is going to pick. Like pick 1, 2, 3, 4, and 5. Nobody else is going to pick that. That sounds stupid, doesn't it? But it's just as likely to win as any other combination of 5 numbers. And then if you do win, you don't have to share the jackpot. Because nobody else is going to win. Because nobody's going to pick that combination of numbers. But they're all equally likely. It's a simple random sample. Okay, next type is called a stratified sample. So what does that word make you think of? Stratified. What's the root word for stratified? This is an English class, right? What's the root? Strata. Good. Strata. So what is strata?
Outside of?
Not quite outside of, but when I think of the word strata or strata, I think of layers of rock, like from geology class, right? And that is what it means. It essentially means layers, or in a broader sense, groups, right? But so a stratified sample, the population is divided into subgroups. We call those strata, but it's in some natural way. So here's their example. I've got Washburn University students. Well, they naturally can be divided into freshmen, sophomore, juniors, and seniors. So those are my strata. Okay? Now, to get a stratified sample, I draw the same number of subjects chosen randomly from each of those strata. So to get my sample of 50, that's not divisible by 4. Oh well. I'm going to take roughly, how many? What's 48 divided by 4 is 12? I'll take 12 from each of the strata and then add a couple, right? That's a stratified sample. So a stratified sample means a few members of each group. Okay? And we use stratified sampling if we want to make sure that each of the strata gets represented in our sample. And a real common one for national surveys is race. They will stratify by race because they don't want any of the minorities to be left out of the sample, which could happen under simple random sampling. It could be possible that there aren't any Asians selected. That could happen, right? But if you stratify, you can ensure. Right? Now, sometimes they stratify in such a way, this says the same number of subjects from each group. But that doesn't have to be that way. You can do what is known as quota sampling or proportional sampling. Suppose you know that in the country or whatever your population is, that the breakdown by race is a certain percentage of each of the races, you may draw your sample with those same proportions. If it's 50% white, then you say, okay, half my sample needs to be white. If it's 20% black, then 20% of my sample needs to be black, and so on. Okay? So that's called proportional stratification or quota sampling. So I'll go ahead and jot that down. Quota sampling proportion mimics population. I won't write this down, but another sort of along the same line is a technique called oversampling. So again, staying with the race idea, they may decide to oversample a certain group because that group is small enough that they know, well, that sample isn't going to be big enough to make good estimates from within that strata, so we need to get 100 extra of that group or whatever. That's oversampling. If you want more information from a certain group, you might oversample to do that, which is valid, but it makes it more complicated type of sampling than what we're talking about here. Okay, the next type of sampling is called cluster sampling. And it starts off sounding the same as stratified sampling. You divide the population into subgroups, only now you call them clusters. But those groups are similar to the population, and you choose whole clusters at random. Right? So a natural type of clustering on a college campus, rather than draw a simple random sample of 100 students, maybe I say, well, there's roughly 25 students in each class. I'm just going to randomly choose 4 classes, and I'll go survey all of the students in those 4 classes, and I've got my sample of 100. That's a cluster sample. Those classrooms are a cluster of students. So the clustering usually occurs in some kind of natural way. When it says the population is divided, the researcher's not doing that division. That division's already out there, and they're taking advantage of it. All right, so when they do national surveys, they usually will cluster sample by city block, because it's more convenient for the researcher to go travel to a single city block and interview everybody that lives on that block than it is to go all over the place. Right? They'll even cluster cities. We're going to randomly choose, and these things all get combined. So a big survey might have stratification by size of city. Okay, cities that have over 2 million, we want to get, some cities from that group, cities that have between 1 and 2 million, and so on. And then cities like Holton with 3,000 people. We need to get some small urban type cities in the sample. And then they'll cluster, say, okay, I've got this many 3,000 population towns, and I'm going to randomly choose 20 of them. And I'm going to take everybody from those chosen towns. That's cluster sampling. So cluster sampling I want to use the word each. Each member from a few groups. So these two have essentially the same thing going on, but the word few and the word each flip. Got it? The book has, in the margins of the book, they have these little things they call memory boosters, and this is one of them. I like those. Right? They're just quick ways to remember, because it's easy to get confused between these. But if you can remember that a cluster you choose at the cluster level and take all the members from a cluster. Stratified sampling, you choose from within the groups, and you only take a few from within each of those groups. So the difference is, where does the randomization occur? Here the randomization occurs within the subgroups. Here the randomization occurs across the subgroups, right? Not at the member level. Okay, the next one is systematic sampling. And this one I already talked about, but you just select every nth member of a population. And they show a conveyor belt with bottles of pop or beer on it, right? And then they circle every so many, every fourth bottle. And that's a common type of sampling for this kind of study. You know, what we call industrial studies, assembly line type studies. Here you're probably going to be interested in the fill level, right? You're supposed to put 12 ounces in a bottle of beer. Well, if the machine is out of whack and it's only putting 11 in there, you need to know that. So they'll take systematic sample all day long. It's not every fourth one, but it's more like every 1,000th one or whatever. But they'll take it all day long, and if they notice it's starting to drift away from the 12 ounces, then they'll tweak the machine. Right? A random sample, a simple random sample, really wouldn't be as good. Because what if you happen to get all of your random sample from early in the day when the machine was still working good? You would miss out completely that the machine started to drift. So each of these things has advantages and disadvantages. A convenience sample. A convenience sample, it says, is convenient for the researcher to select. What the heck does that mean? Give me an example of a convenience sample.
Needing a study and just choosing the people around you at that time.
Okay? Choosing the people around you, the people that are handy. How did you select your sample? That's due tonight by midnight, by the way. How did you draw your sample? What's your name? Yeah, you.
Claire.
Claire, that's right.
Definitely convenience. I just call all people I knew would answer at the time.
Called the people that she knew would answer, right? Friends, family, that kind of thing. All right? That's a convenience sample. And I can guarantee you that every single one of you used convenience sampling. How would you have done true random sampling? Go to the union and ask strangers. Is that a random sample? That's a convenient sample too. It's not as convenient as asking your roommates and your mom and dad or whatever, but it's still convenient sampling. You ever go to the mall and you're riding up the escalator and you see this lady standing at the top with a clipboard? She's convenience sampling. And you're trying not to make eye contact because you don't want to have to stop and answer questions, right? That's convenience sampling. Typically not a great way to sample, although the book gives some examples of times when it is useful to convenience. I was actually involved in a convenience sample where we were interested in the responses of people who were sitting around in doctors' offices, waiting rooms, right? And so they were convenient to us. Here they are. They're downstairs. I was at KU Med, and they're downstairs in the doctor's offices. So we just went and interviewed them. Right? Convenience sample. But when we wrote the paper about it, we had to say, this was our sampling technique. We understand this is possibly biased, but this is what we got. Now, the one the book does not talk about is a type of convenience sample, a voluntary response sample. And I'll start off by saying, don't ever trust the results from a voluntary response sample. They're just bad. What it means is, and oh, by the way, there's a typo on this slide. I added this slide because the book doesn't talk about voluntary response. I can't write it because there's no board behind it, but put the word non in front of random. This is a main type of non-random sampling method, right? Because voluntary response is certainly not random. So what the heck is it? Well, it's like if you go to a website, you're on Facebook or whatever, and up pops this little window, and it says, hey, what do you think about gun control? Take our survey. Click yes or click no. That's a voluntary response. You cast a really wide net. You know, they'll even do it on the news sometimes. What is your opinion? Or they do those news magazine shows like Dateline, NBC, and they'll say, do you think he's guilty? Call this number if yes, call this number if no. Right? Those are voluntary response samples. Do you trust the results from those things? Who takes those surveys? You're smiling like you do. I do it as a goof. Who does? Well, what you can show is that folks who have a strong interest. So if it's about gun control, who's going to click on the button? People who care a lot about whether or not we have gun control legislation. The rest of us are like, I'm not going to waste my time with that. Right. So don't ever trust the results of a survey like that. And if you're reading the results of some survey, ask yourself, was this a voluntary response survey? And if it doesn't tell you, then quite likely it was. Because that's not something they're going to brag about. So if they won't tell you how they drew their sample, then I wouldn't put a lot of faith in the conclusions that they draw. Okay, so identify the type of sampling in each of the following scenarios. First one says, a pollster surveys 50 people in each of a senator's 12 voting precincts. What kind of a sample do we have there? I heard cluster. I heard something else that I couldn't hear. Stratify. One of those is right. Which of these does it meet? A few members of each group, or all the members from just a few of the groups? Pollster surveys 50 people in each of the 12 voting precincts. So the precincts are the strata, and they use a few from each. So that's stratified sample. Next one, quality control department at a cereal manufacturer measures the weight of every 10th box. Systematic sample. A female student walks down the hall of her dorm asking students how much money they would spend in a food court in the dorm lobby. Convenience sample. That's a convenience sample. An educator chooses 5 of the school districts in the Chicago area and asks each household in those districts how many school-aged children are in the home. That's a cluster sample. You've got a whole bunch of school districts. They randomly choose 5 of them, and then they survey all of the households in the 5 chosen school districts. Last one, to determine who will win a $100,000 shopping spree at the mall, the manager draws a name out of a box. Excuse me. That's a random sample. If it was more than one, that would be a simple random sample, but they're only drawing one, so random sample and simple random sample are the same thing when there's only one, because all groups have an equal chance of, all groups of size 1. Say that again? I don't know if the PowerPoint presentation is, especially not my modified one, but I can post it out on D2L if you're interested in it. I've already posted it for my online class, but I can do it for you guys. So I think all of the things that are in here are in that Learn module as you go through, and a lot more. But okay, so we'll quit there. Like I said, I did not finish this section. I will pick it up Monday from where we left off. So don't forget, you got 3 things due tonight. Otherwise, have a great weekend.